Now, this is a pretty interesting problem which can be solved very easily if you have practiced a lot and you have a bit of intuition also. Now for solving this question, let us read the question first. There is a hydrogen-like atom with atomic number Z, which is in high energy state of quantum number n. This excited atom can make a transition to first excited state. Let us draw the diagram. This is n is equal to 1, 2, 3, 4. Note that the gaps keep reducing subsequently. N is equal to 5, n is equal to 6, this is n is equal to n. This let it be in some excited state n initially. This excited atom can make a transition to the first excited state, that is equal to the second state, that is here, by successively emitting 2 photons of energy, 10.2 electron volt and 17 electron volt. That is, that it emits 2 photons. Let it be something like this. The total energy difference between these two states comes out to be equal to 10.2 plus 17, that is equal to 27.2 electron volts. Now let us read the question further. The atom from the same excited state, that is n, can make the transition to the third state. The third state is this one. It had previously come to this place. Now can make a transition to the third state by emitting 2 photons of 4.25 electron volts and 5.95 electron volts, the addition of which gives 10.2 electron volts. So the atom from this state to this state has an energy difference of 10.2 electron volt. Now, to the third state, this is some nth state. Now, we can see clearly from this diagram that the energy difference between the n is equal to 3 state and n is equal to 2 state is equal to 27.2 minus 10.2 electron volts. Therefore, we write the energy difference between the third state, 13.6 z square. We know the energy difference between two states can be written to be equal to 13.6 z square into 1 upon n1 square minus 1 upon n2 square. Now, therefore, using this we write down the ionization energy of a hydrogen atom is given to be 13.6 electron volts. That is what we use over here. So, 13.6 z square into 1 upon n1 square, let us write down for 2 and 3, 1 upon 2 square minus 1 upon 3 square, this is equal to 15 electron volts or 17 electron volts, sorry. So this comes out to be equal to 13.6 z square into 5 upon 4 into 9 is equal to 17. Therefore z square comes out to be equal to 17 into 36 upon 5 into 13.6. So from here we see that this can be written as 17 into 4 into 9 upon 68. This gets cancelled, this is equal to 9. Therefore z is equal to 3. So we get the answer for z directly, that is the atomic number of the element is equal to 3. That is, it is a lithium of 2 plus ion, because the atomic number 3 and it has to be a single electronic species, therefore it is Li2 plus. Now as we know the z, one can now easily solve the question by writing down the equation for the energy difference between n is equal to n and n is equal to 3, or n is equal to n and n is equal to 2. You can use any equation. So we write 13.6 into z squared, that is 9, into 1 upon, let us write it for n is equal to 3 to n is equal to n, 1 upon 3 square minus 1 upon n square, this is equal to 10.2. On solving this, you will get the answer definitely to be n is equal to 6. I can tell this directly also. Why? Because here's another trick. Let me draw the energy states for a hydrogen atom. For a hydrogen atom, the energy states are something like this: n is equal to 2, n is equal to 3, n is equal to 4. You should remember the values for the energies of these levels. This is minus 13.6 electron volts, this is minus 3.4 electron volts, this is minus 1.51 electron volts. You should remember these values somewhat, and you should also remember this energy difference, that is 10.2 electron volts. Now an energy difference of 10.2 electron volts between states 1 and 2 in the hydrogen atom will be equal to the energy difference of 10.2 electron volts in the helium atom from states 2 to 4. This same energy difference of 10.2 electron volts will exist between the states n is equal to 2 and n is equal to 4 for helium plus ion, and this same energy difference will occur for between n is equal to 3 to n is equal to 6 for lithium 2 plus ion. This can be easily checked by writing down the equation, and this can easily be proved also for writing down by writing down the equation for the energy difference, that is 13.6 n z square into 1 upon n1 square minus 1 upon n2 square. So we conclude one more important trick here, that an energy difference of whatever E between the states n is equal to 1 and n is equal to n for H atom 1 to n will be having the same energy difference as that between 1 to n of H atom between Z to Zn states of an element of atomic number Z, just like transition of 1 to 2 in H was equivalent to transition of 2 to 4 in He plus, and this is also equivalent to 3 to 6 in lithium 2 plus. So this is an important trick that you can remember. That is why I also remembered the value 10.2 electron volt. So as soon as I saw 10.2 electron volt, one thing struck to my mind, that this is equal to energy difference of 2 to 4 or 3 to 6. That is why I was able to solve the question very fast. So without that also you could have solved the question like I did the question, by analyzing that the energy difference of that is given between n is equal to 1 and n is equal to 2 and n is equal to 3 and n is equal to 4 and n is equal to 3. The subtraction comes out to be equal to a value equal to that between n is equal to 2 and n is equal to 3. So final answer for the value of Z comes out to be equal to 3, that is it is Li2 plus ion, and the value of n comes out to be equal to 6, that is it is initially in the energy state of quantum number 6 and its excited state is 5th. So final answer is Z is equal to 3 and n is equal to 6.